Hello, and thank you for joining. My name is Gagan Brahmi, and I am a Senior Analytics Specialist Solutions Architect at AWS. In this Analytics in 15 session, we are going to talk about how you can build Apache Spark applications and integrate them with Amazon Redshift. We will also discuss some additional data integration and federation features for Amazon Redshift. Let's get started. Tens of thousands of customers use Amazon Redshift every day to run data warehousing and analytics in the cloud and process exabytes of data for business insights. Amazon Redshift is a pioneer in this field. Introduced in 2012 as the first cloud data warehouse, we haven't stopped innovating since then. Whether your growing data is stored in your operational data stores or your data lake or streaming engines or within your data warehouses, Amazon Redshift helps you securely ingest, combine, share data, and run analytics in just a few clicks with minimal data movement or copying. Amazon Redshift Serverless enables your engineers, developers, data scientists, and analysts to get started with analytics quickly in a zero administration environment. With AWS designed hardware, its massively parallel processing engine, and an architecture that separates compute and storage for efficient scaling and machine learning driven performance insights, Amazon Redshift delivers up to 3 times better price performance than other cloud data warehouses. Let's talk about Amazon Redshift integration for Apache Spark. Before the release of Redshift integration for Apache Spark, developers have been using Spark Redshift open source connector. However, using the open source connector involves manual setup, maintenance, operational overhead. With Redshift integration for Spark, the need for manual management and maintenance is eliminated, allowing developers to seamlessly integrate Spark applications to read from and write to Amazon Redshift data warehouse. Starting with Amazon EMR version 6.9, Amazon EMR Serverless version 6.9, and AWS Glue version 4.0, you can leverage Amazon Redshift integration for Apache Spark. This integration allows a number of Spark data frame API operations to be pushed down to Redshift, which results in a superior performance. With this pushdown capability, only relevant data is pulled from Redshift, which results in minimal data movement. Using this integration, you can make use of AWS IAM-based authentication for an improved security posture. Let's see the Redshift integration for Spark in action through a demo. We have Example Corp, a fictitious company which provides ticket sales for live music and sports events across the country. With a highly competitive segment, they want to ensure that they stand out amongst their customers by offering tickets at a lower price point. The leadership at Example Corp has decided to leverage artificial intelligence and machine learning to forecast sales for the upcoming events. This will help them remain competitive and set prices which are attractive for their customers. Currently, Example Corp is storing their sales data inside Amazon Redshift. The data engineering team is assigned the task to prepare the historical ticket sales data with the sales for each week. This curated data will be used to train and build a machine learning model using a custom algorithm. The data engineer would be using Jupyter Notebook with Amazon EMR Studio, which is attached to an Amazon EMR cluster, to read the relevant data from Amazon Redshift cluster. In this demo, we will be using PySpark, which is an interface for Apache Spark in Python. Amazon Redshift integration for Apache Spark can also be utilized via Java and Scala interfaces for Apache Spark. We will also take another example where we will cover the same example, but this time we will use Apache Spark with AWS Glue, our serverless extract, transform, and load, or ETL service. It will consume the data from Amazon Redshift. The consumed data will then be stored in Amazon Simple Storage Service, or Amazon S3, for training the models. Let's head to the AWS console to see this in action. We are in the AWS console inside the Redshift console. We already have a Redshift cluster created. Let's take a look at the data that we have inside this cluster. We will use Amazon Redshift Query Editor v2 to take a look at the datasets we have. We connect to the Redshift cluster. We expand the database dev. We then navigate to the schema ticket. And then we take a look at the list of the tables we have. We have different tables, including category, date, event, listing, sales, and users. Now, the data engineer is using Jupyter Lab, which in this case, we are using a Jupyter notebook through Amazon EMR Studio. The Amazon EMR Studio is attached to the Amazon EMR cluster, where we are going to execute the Spark applications. Let me go ahead and execute all the cells, and I'm going to come back and explain what is happening in all these cells. So we first start by defining the Spark configuration, where we are exporting the jar files. And the next cell, we are importing some Spark modules and initializing a Spark session. We are naming the application as Spark Redshift Connector. Next, we are defining the variables which will be used by the Jupyter Notebook and Spark application to connect to Amazon Redshift cluster. Most importantly, the JDBC IAM URL using the IAM authentication protocol for Redshift. We define a temporary directory where the temporary data would be stored by Redshift. We also define an AWS IAM role, which has the permissions to request temporary IAM credentials to connect to the Redshift cluster. A notable configuration parameter or variable we're defining here is a query group. This query group would be used to query a system view to retrieve the last SQLs executed on the Redshift cluster. We are defining the usernames, and next we create a Spark data frame. In this Spark data frame, we are reading two tables, sales and date, within the ticket schema. We're going to perform an inner join using a date ID as the column. We will then apply the filter and look for data only for the year 2008. We're going to aggregate the quantity sold and group it on a weekly basis, and we'll sort the output by week. Lastly, we're going to rename the columns of quantity sold to total quantity sold. Now it looks like the execution of the cell is complete, and we see some relevant data here. In the next cell, we are querying the sysquery history system view to retrieve the SQL executed in our previous command. We are also passing the query label that we've defined in our previous execution, which is spark-redshift-emr. Now, as you can see, the previous query that was executed by this query label was an unload statement on the Redshift side. The most important things to note here is that this query actually pushed down a lot of operations, including the inner join, the aggregation for sum total of all the sales. It also performed the group by, and it also converted the sort from Spark into a more optimized order by on the Redshift side. At the same time, you can see that it used the temporary location that we provided and stored the temporary output in an optimized columnar parquet format. Now the data is available in the Redshift, from the Redshift into the Jupyter Notebook. Data engineers can make further modifications or plot them to look at specific interesting areas that they may want to take a look at and see patterns. Now let's head to AWS Glue and take a look at the second example that we talked about earlier. In AWS Glue, for you to use the Redshift, the Amazon Redshift integration for Apache Spark, you have to define a data connection. You start off by navigating to data connection, click create connection. You define a connection name. In the connection type, we select Amazon Redshift. We choose the database instance we want to connect to. We provide the database name, and we provide the credentials or attach the secret, which includes the credentials. Now, for the purposes of this demo, I've already created a connection for you. And this connection is having all the right connection for our Redshift cluster, the username, subnet, and security group. You can create a job, and I already have a job created here. We will create a job and attach this connection for Glue to use the Redshift integration for Apache Spark libraries, which are made available through Glue as well. Let's take a look at this job to understand more. But before that, I'm going to save some time and click run and I'm going to explain what's happening in this job. The job is running, and let's take a look at the script. So we are importing some standard libraries for Glue and PySpark. We are initializing a Spark context. We are also setting up a Glue context. And we define the parameters, the JDBC IAM URL, the temp directory, the AWS role through arguments that we are supplying to this Glue job. Important change here is that the query group is glue-redshift, which we will use to query and retrieve the results. And the other notable difference here is that in this case, we are going to write the results back to our Redshift cluster under tickets schema with the table name test-glue. The other notable configurations we have to keep an eye on is inside the job details. We are using the Glue version 4.0, and in the advanced properties for the Glue job, we are attaching the connection that we have created for the purposes of this demo, where we want to utilize this Amazon Redshift integration for Apache Spark. Let's take a look at the runs and see how the job is performing. So it looks like the job is still running. We'll give it a couple of minutes before we come back and take a look at the execution. So it looks like the job has completed successfully. Let's head back to the Redshift query editor, and we now have 8 tables. And as expected, we have test glue as a new table. Let's query this table. And we have an expected output result here. Now let's run a query against this query history, this time looking for query label glue redshift. So I will copy this output and can transfer it into a text editor to have a better visibility. So as expected, we have this unload statement on the Redshift side that Glue has initiated, or Spark from Glue has initiated. We see the same behavior, some of the aggregations, including the sum that's being pushed down. We also see other interesting pushdowns, which includes the inner join, the order by, and the group by on the Amazon Redshift side. So to recap, with Amazon Redshift integration for Apache Spark, you can get started within minutes to access the data from Amazon Redshift using Apache Spark-based applications. Developers no longer have to spend time on downloading and maintaining the latest version of connectors, which is often the case with the current open source connector. We use AWS IAM role to securely access Amazon Redshift cluster when consuming the data. As demonstrated in the example, many of the operations are pushed down to Amazon Redshift, which results in lesser data being moved back to Apache Spark applications, which in turn improves the application performance. Let's talk about a few more data integration features for Amazon Redshift, starting with streaming ingestion for Redshift. With Amazon Redshift streaming ingestion now generally available, you can configure Redshift to directly ingest streaming data into your data warehouse in real time, right from the Redshift console. At reInvent last year, we announced the preview of zero ETL integration between Amazon Aurora and Amazon Redshift. Within seconds after your transaction is committed to Aurora, it will be made available in Redshift for analysis. This feature eliminates the need to build and maintain complex data pipelines to perform extract, transform, and load, or ETL operations. With this Redshift zero ETL integration with Amazon Aurora and Redshift streaming ingestion, performing near real-time operational analytics has never been easier. With Amazon Redshift auto copy support, users can now set up continuous file ingestion rules. The rules track your Amazon S3 bucket S3 paths and automatically load new files without the need for additional tools or custom solutions. Autocopy for Amazon Redshift simplifies data loading from Amazon S3 into Amazon Redshift. AWS Data Exchange for Amazon Redshift enables you to find and subscribe to third-party data in AWS Data Exchange that you can query in an Amazon Redshift data warehouse in minutes. You can also easily license your data in Amazon Redshift through AWS Data Exchange. This feature empowers you to quickly query, analyze, and build applications with third-party data. For example, Moderna used Amazon Redshift and AWS Data Exchange integration to subscribe to real-world evidence data in real time to create a new generation of transformative medicine using their mRNA technology. Thank you for joining me today. Be sure to check out additional resources for Amazon Redshift and AWS Data Lakes and Analytics page to learn more.